right, can folks hear me? All right. My name is John Allspaw. I run the operations group at Flickr.
And my name is Paul Hammond, and I run the engineering group at Flickr.
Today's talk is going to be a bunch of different topics, actually. A vehicle, if you will, to describe how development and operations fits together and gets along, actually work together and aren't huge assholes to each other at Flickr.
But before we get started, we should talk a little bit about what Flickr is. Can anyone raise their hands if they've heard of Flickr? Okay. So for those of you who don't, Flickr is a photo sharing website. At the moment, we store around 3 billion photos. And at any given second of the day, we serve around 40,000 of those photos per second. They take up about 6 petabytes of storage. You know,
that's a lot of kittens.
There's a lot of, yeah, it's big.
So we're going to talk about dev and operations. Historically, traditionally, even now, this is usually thought of as dev versus ops. Heidegger's keynote had the graphic of, two guys like this. You hear a lot of this. It's not my machines, it's your code.
And then you hear me saying, it's not my code, it's your machines.
This sort of behavior here and stereotype creates these sort of archetypes of developers and operations. Some developers might be construed as a little bit weird. They're really up high in math land, and the ops guys, man, they freak out every time something goes wrong, and they're easily excited. They may or may not drink too much. So what this, in all seriousness, what this leads to is this stereotype of. Go ahead.
The other stereotype we think of when we think of operations people is of a grumpy old man.
Yeah.
A grumpy old man that says no all the time. They're afraid that all these newfangled things are just going to break the site. Very, very finger pointy, full of blame.
Yeah. So they say no all the time because the site breaks unexpectedly, because no one tells them anything, because they say no all the time, Now that stereotypical ops manager grumpy guy is the guy that says, no, I don't want to do that. Well, who wants to work with that guy? Nobody, because the guy's a prick.
So when we look at the roots of these kind of stereotypes, it comes back to traditional thinking about the role of developers and the role of operations. The way most people think about it is that developers' job is to add new features to the site, and operations' job is to keep the site stable and fast.
That's true, right? Or is it? I don't think that ops' job is to keep the site stable and fast. It's not their job. This might be a newsflash to some people. Ops' job is to enable the business, right? If the business requires that the site go down every 2 weeks, even though you're the largest online gaming platform and you have millions of paying customers, those paying customers might be quite fine for you to have availability of 97%. Screw the 5 nines. And this is just truth. It just so happens that keeping the site stable and fast is something that you see as common across business requirements. Speaking of business requirements.
So one of the realities of working in a business, particularly online businesses, is that the business requires change. If your business is standing still, then you're going to get taken over. You're going to be overtaken by some upstart like Twitter or Facebook.
Jerks.
The problem you have, of course, is that change, if you look at the root cause of most outages and you generalize, then you come to the conclusion that change is that root cause of most outages. Most outages wouldn't happen if there hadn't been a change a few days, a few hours, a few weeks previously.
So you get 2 options. You can discourage change in the interest of stability. I'm old, no. Or you can be smart, and you can build tools and culture to allow change to happen as often as it needs to.
So that's what we're going to be talking about today. Most of what we're going to be talking about is lowering the risk of change through good use of tools and good working culture in your team. What we're trying to do with a lot of these tools is increase the confidence that any given change isn't going to cause an outage or some kind of problem on the site. And then we're also going to look at ways that you can increase your ability to recover from those outages should they happen.
Of course, what really helps in this regard is when you have operations people who think like developers.
And developers who think like operations people. There's probably a bunch of you in the audience that are thinking, that's me.
I do that.
I do that already. So we're going to do some more hand raising, and it's a bit hard to see because there's some really bright lights, but how many of you in the audience consider yourself to be a developer?
That's a lot.
Third, I guess. How many of you consider yourself to be on the operations side of the fence? About 2/3. And how many of you are in a job at the moment where you're doing both? It's a handful. So of the operations people in the audience, how many of you have changed user-facing application code recently? It's a handful.
How many of you work with developers that are happy that you made those changes? There's something funny about that.
Of the developers, how many of you have worked out of hours because there's been some kind of site problem and you've got phoned on an evening on a weekend? So that's maybe a third of the developers in the audience. How many of you carry a pager? Or on call?
Who are developers?
Who are developers. And of the developers, how many of you know how many web servers you can lose before your site falls over completely?
Okay. These are always good questions, I think. The answer is, you can always think more like them. Yeah.
Yep. So, we're going to talk a bit about tools now. And what we're hoping to do in this discussion of tools is, these are some of the tools that work for us. They're not necessarily going to work for everyone, and throughout we're going to give examples of the specific tools that we use, but the important thing that we're trying to get across is the concepts that are important. And this is going to be a common theme throughout this conference, but if there's one tool that you put in place, if there's one kind of technique that you use, automated infrastructure is that technique. It just makes the operations job possible. If you've got more than a dozen servers, then manually managing every individual server is just not really an option. And from the developer's point of view, it gives them a consistent, predictable platform that they're building their app on top of. It means that they don't have 10 web servers running Apache 1.3 and then 3 web servers running Apache 2.2. Unless you're in the middle of an upgrade, in which case they'll know that that's happening. Yeah. But without that consistent platform, it's really hard for the developers to do their job.
So we've got all kinds of tools. This talk isn't about that. Adam and Ezra are going to give a talk a little bit later about it, and half a dozen better presentations on the topic. But the main point here is you have this idea that you've got an OS image, and you've got some sort of role that this server, this piece of infrastructure or cloudy bit actually performs. It's a task-driven infrastructure. And really, there's no difference. The difference between this and the cloud is that this has a blue cloud around it. And that's it. It's still the same idea.
So if you're running your servers on, say, EC2, then the OS imaging side of things is taken care of by AMIs, but you'll still need the role and configuration management layer on top of that.
Yeah. Maybe even more importantly.
The second tool we're going to talk about is version control. And I don't know many development teams that would even try and operate without version control. And increasingly, I'm seeing more and more operations teams using version control. Mm-hmm. But something that, in fact, we even used to do. It used to be the case that Flickr source code was in CVS, but all of the operations, all of the packages and all the configuration management was stored in Perforce. And what that meant was that the developers had no idea what was going on. I had no idea how to check out the Perforce repository. John had no idea how to check out the CVS repository. By having one shared revision control system, then everyone on your team knows where to look to find the latest instance of the configuration for a particular box, or they can see what's going on in the application and where the changes are. Mm-hmm. This is really, really useful when you have an emergency. On Friday, I got phoned up. I was out having a meal, and there was a problem with part of our site. And Kevin, who works on John's team, phoned me up. And because we have one single source code repository, then I was able to talk through over the phone what the single change that needed to be made to mitigate the problem that we had was. If we had different source code repositories, then maybe Kevin wouldn't have access to it. You know, I'd have had to have gone home, got out my laptop, and made the fix myself. And so this single source control, it provides transparency, and that's a very useful thing. From a development point of view, one of the most important things you can do is to set up one-step build. And what we mean by that is everything you need to do to take the code that is currently in your source control system in SVN and turn that into a set of files that can be copied onto a production server and run the site. The screenshot that I'm showing on the screen right now is part of Flickr's internal development admin interface. This is the stage and build, the build and stage button. The button at the very bottom of the screen, the one that says perform staging, you click that button, it performs an SVN checkout. It does all of the translations, it compiles all the templates. Anywhere where we have compilation that we do for optimization, it does all of that, and then it copies that code onto a staging server so that we can test it.
Automatically.
Automatically.
Which means that you don't have people running this command and then you run this command. As it turns out, computers are really good at running commands the same time and or the same order over and over again.
You also don't get the situation where a developer has done a build on their workstation and that has subtly different configuration than developer 2, and so subsequent changes, even though maybe there's no significant change in the code, the application behaves very differently when it's deployed. And once you've got that one-step build, the next thing you need is a one-step deploy. This is Flickr's internal admin tool for deploying. At the top, we have a deploy log, and that's a very, very cheap form of change management. It means that everyone can see what's going on and can warn that maybe now isn't a great time to deploy because there's some other change going on elsewhere in the system. And at the bottom, we have a button. It says, I'm feeling lucky, and you push that, and it pushes the code out to the site. This is what it looks like when you're pushing the code out to the site. And the same principles apply here. By making it one button, it means that there's very, very little room for error. It means that you're doing your builds and you're doing your deploys in a consistent environment. It means that there's no manual steps that might go wrong. And so if you're looking at the diffs in source code, then you can be fairly confident that that's going to be the only difference that you can see in the behavior of the application when it's deployed.
And this is the way we do things, but you see this as a trend. Continuous deployment and continuous integration is starting to show up in a lot of operational tools and even vendors selling things and open source projects as well. So it's just a good idea. One of the greater things about this process is now we have a deploy log. Let's just not skip over that for a second. We know who, we know when, and we know what. This is really, really important. John Adams showed earlier, they put, we'll talk about it later, but they put the deploy timestamp at the top of their monitoring and metrics tools. Context is absolutely everything. And the title of the talk is what, 10 plus deploys a day? You can't pretend or try to deploy 10 times a day if you go down 10 times a day. That's not being agile, that's just being retarded.
One of the points I want to get across here is that it's not just about having a one button on a web page that does the entire process. It could be that you have a make script, a make file in the root of your source control. When it comes to deploying, it could just be that you have a shell script that you run. It could be that you use Capistrano. It could be that you use, I don't know, RPMs. And so the deploy system that I just showed you is how the main Flickr application is deployed. One of the things that we're starting to experiment with some of the smaller apps around the edges is to use a continuous integration server. We're using Hudson to automatically generate packages that then can be deployed to boxes by the operations team. Again, it's a single-step build. You commit the file to SVN, and that you can push a single button in order to generate that package, and then a single-step deploy, which is just someone from the ops team will then actually deploy that package.
Or a dev.
And yeah, as John's already mentioned, because our build and deploy system is completely automated, we can do it more often. And that allows us to make each deploy smaller. So each individual deploy introduces less risk. And should anything go wrong, it's significantly easier to work out what might have happened so that we can recover. The next thing I'm going to talk about is, again, quite developer-focused, and that is what we call feature flags. You can also think about this as branching in code. When you think about revision-controlled branching systems, they're a reaction to a reality of building desktop software. You're Microsoft. You've developed Microsoft Word. You launch Microsoft Word 1.0. And then your development team immediately starts working on Microsoft Word 1.1. And you launch 1.1. And then a few days later, you realize there's a critical security vulnerability. So you have to go back to the 1.0 code base and make a change to it and ship that. And then you release 1.2. And then you have to make another change. And so you're releasing 3 different versions of your software at once. For those of us that have a single instance of our web application, that's not the case. All that we have is what is currently deployed, and any old versions don't really matter anymore. The way we deal with that is that we always ship trunk. That's not to say that we do all of our development on trunk, although we do. You could do your development in branches and then merge those branches, but by always shipping trunk, it means that everyone on the team knows exactly where to look for the version of the code that is currently deployed on your site. It means that you don't have to wonder which branch of which patch release is the one that's currently released. You just go into SVN, and it's there, it's trunk. I mentioned that we don't do branching in SVN. We do our branching in code instead. And what that means is whenever we're developing a feature that we don't want to launch straight away, then we block out those particular code paths using conditionals. So here's an example from PHP. Here's an example from Smarty. And that means that we can actually we have all of the code for every new feature that's not yet released in production on our production servers. It's just the config is set up so that it's not actually visible yet.
And if you can't tell where we're going with that, you'll see a little bit later. That smells a lot like an operational lever. Talk about that later.
We'll get to that in a minute. This allows us to do a couple of really neat tricks. The first is it allows us to do private betas on production hardware with production traffic. Now, obviously, we have some really great staging environments that are a pretty realistic test, and we do a lot of QA in those environments. But something we found out is that if you use a second set of servers for your testing, then you might not notice changes in configuration between your beta servers and your production servers. Even with configuration management, it happens. And we've had cases in the past where a new feature worked perfectly on our beta servers, and then the moment we pushed it into production, we realized that the back-end internal web service that we were relying on was blocked from our production dubs. And so the feature didn't work. We had to put out an emergency change request to that back-end web service. It allows us to do bucket testing. And this is incredibly useful. It means that if we've got a new code path, if we've got a new back-end system that we're thinking about using, we can start to just push 5% of traffic to it, and then increase it 10, 20, 30, 50. We can turn on a feature for a subset of users, and we don't have to do any careful juggling with having different versions of the software running on different servers and pulling boxes in and out of production. We can just do it all in code. And lastly, it allows us to do dark launches, which is something Jonathan mentioned when he was talking about Facebook earlier. We launch new features behind the scenes. So if we've got a new feature that's going to cause more load on our memcache boxes, on our database servers, on our search cluster, then we just turn that feature on behind the scenes and start fetching the data for a few weeks, but not show that data. And then when it comes around to actually launch this new feature, we know we're going to be able to take the load because we've been taking the load for several weeks.
It's a huge boon for operations because it just takes the suspense fear out of the gig in a huge way, right? It means that. Did you give the example of the new Flickr homepage?
I didn't know.
Yeah, so I mean, we redesigned the new Flickr homepage. It's got a lot more information, basically activity from your contacts and various amounts of activity streamy real-time stuff. It's a huge shitload of data, right? And so what are we going to do? Every homepage that we're going to serve is going to grab a boatload more data from the databases. Well, databases suck. That's a huge pain in the ass and really scary. So we did it. We dark launched it for a number of weeks.
Yep.
And the application just takes it and then chucks the data. Well, it made the actual launch completely anticlimactic, which is a really good thing.
Do you want to talk about this?
Yeah. It should be obvious at this point. These feature flags or disable flags, how many do we have right now? Probably
a couple of hundred.
We've got a couple of hundred. We can just turn things off. Or we can change the behavior of things that are affecting the site, either availability or performance. If a database cluster happens to have some degradation or some other back-end service has some degradation and it's feature specific, then we can change this and without affecting the site, And do we roll back? Kind of, not really, very often. What we do is we roll forward and just turn shit off. Some of those feature flags also aren't just on or off. Some of them are, like Paul said, some of them are knobs that have, variable amounts. So it's good. Shared metrics, just like version control, just like having shared version control, you can see my bits, I can see your bits. Well, we gather metrics, right? We gather shitloads of metrics, we gather all kinds of metrics, right? Here's a screenshot of our Ganglia install. And we've got something like 37 different clusters. I don't know how many tens of thousands of metrics we grab at any given second. The important point here is that devs not only know where this is, they have access, and they watch it just as obsessively as operations. If you walk around the office, all the developers have, at least in one tab on their browser, something like this. And part of this, because they know where it lives, it means that we can squirt application level metrics in there. CPU and network and memory and disk, all those things are, all very important. But they are really important when in the context of the application, right? I don't care if you're doing 75% user CPU. How many of that, what that role is, if that server is doing widget eating, how many widgets is it eating per second for each piece of, each bit, each percentage of CPU? This obviously comes into capacity management and capacity planning and all that sort of stuff, if you think that's important.
So this is a graph of, what is it?
This is a graph of the average over the last minute of a particular server that does image processing. So when you upload your kitten to Flickr, we cut it up into 5 or 6 different sizes. And this gives you how long it took to process each one of those on average.
And this is a graph of how many background tasks we have in our asynchronous task queue. And one of the interesting things, I actually made the metric that is being shown in this graph. And one of the reasons I made this graph not because I was asked to by John's team. I made this graph because I wanted to have some idea of how our offline task system was performing. The interesting thing here is we've got this dynamic where the developers want to make these traditionally operational metrics, and John's team make it easy for us to make these. We have a framework now where any part of the application will just write a file that has key value pairs in it, and our Ganglia setup will just slurp it in and make pretty RRD graphs for us. This then leads to us creating adaptive feedback loops in the application. So where we have things that are happening asynchronously, then we can have the application start to back off and try and put less load on the system if the system isn't performing well. So the offline task system that I just mentioned, it will actually dial back if the databases are starting to get overloaded to make sure that the databases are there to deal with the real-time load. Because if we need to run an offline task 10 minutes later, that's not a big deal. Yeah. And when we did the migration from Yahoo Photos to Flickr, then we throttled that based on the amount of free disk space left on our storage to make sure that we didn't run out of storage.
Yeah, that was a really good example. So we've got this multiple month process, right? They're shutting down Yahoo Photos. One of the options to do with your Yahoo Photos is you can go to Shutterfly or a couple other places, or you could migrate them to Flickr, right? So essentially, what is it? It's an enormous, massive exercise in queuing asynchronous tasks. It's going to take shitloads of time to get all of your 10 years of Yahoo Photos imported into Flickr in the format that Flickr has with all of the metadata, and it's going to take a long time. So it's going to have to be, yes, I'd like to move to Flickr. Okay, we'll let you know. And this is petabytes of data, petabytes of shitloads of database data, but petabytes of image data that need to be processed to the different sizes because there were large differences between Yahoo Photos and Flickr. And so as far, we're pretty tight on and pretty dialed in with how much storage is going to come online and when. But what we didn't know is the huge unknown variables, how many people are going to click that button and say, yes, let's go to Flickr. Well, that was really variable depending throughout the entire length of the migration. So measuring when we're going to, predicting when we're going to run out of space and changing the migrations to adapt to that was a huge win for us.
John's kind of stolen our thunder on this one, even though it was our idea.
Yeah, Adams. Twitter.
Sure.
But he gave us credit, right? We do this. I actually said it already. We do put the time of the last site deploy up on every page of every metric we have.
And that often makes it quite easy to work out why a particular graph has just doubled or halved. This was an example where one of my team rolled out an optimization to our image processing code, and we weren't sure what effect it would have. We thought it might be a little bit, and it turned out to be quite a lot.
Communications. We're starting to get close towards the end of the tools bits here. We use a lot of IRC at Flickr, like a lot of other places, and we use it for ongoing dialogue between developers and operations. What's going on with the site? What are you working on? We've got a lot of people with a lot of balls in the air, and IRC is helpful, especially for people who work remotely. So we've got this conversation going on, and it's good to have context. So we do something, Last.fm actually wrote a great little tool to do something exactly like this. We squirt events, computer-driven events, into the stream in IRC. So for example, certain alerts and monitors that we really care about, build logs, the deploy logs, when something was deployed. So, you're having a conversation. I don't know, I'm having this problem with some rewrite rules and deploy. And I don't know, what do you think about that? I don't know. Alert. So then what we do actually is we take all of this logged information and we shove it into a search engine. So we can say, what the hell did we do on Thursday 2 months ago? What was going on? Did we see this problem before? So it really, really helps because it means that humans now have context and not just, RRD tool back in time context. There's actually human context, which leads us to.
So all of these tools won't really help you if you install them, but you still have that incredibly argumentative, combative culture going on. And one of the other things that we think makes our working life so much easier is the culture that we have at Flickr. Just like automated infrastructure, it's like ground zero for, like the very basic thing that you need to do in terms of tools. When it comes to culture, the most important thing, the thing you need to start with is having a culture of respect. It's a bit hypocritical of us saying this, isn't it? But one of the most important things you can do is to avoid stereotypes. I know that you worked with a cowboy 5 years ago that just didn't care about your application or just didn't care about your system uptime. But not all of the developers that you're going to work with are as bad as him, and not all of the operations people are going to be as obstructive as him. Mm-hmm. If you assume the worst in everyone, then everyone's going to assume the worst in you. Mm-hmm. Everyone is a delicate little snowflake. Everyone is a little bit different.
Every one of you. Every one of you.
It's important to respect different people's expertise and different people's opinions, because they have different experience and they're going to come up with different solutions to problems than you. And those solutions might not be the best solution, but you should at least respect their suggestions. Yeah. The other thing that's really important is to respect different people's responsibilities. We all have different responsibilities to the business. John is the one that's going to get hauled in front of management if Flickr has too much downtime. I'm going to get hauled in front of management if we don't launch any new features in the next 2 years. And so that means that we are going to have different priorities. And it's important to understand and recognize and like I say, respect those.
Mm-hmm. Part of that is when you have conversations about problems. You know, just saying no is another way of saying, I don't care about your problem. You can't write a Bloom filter, so screw you. Finding out what problem are they trying to solve. If it's a developer trying to fix a problem or an operations person trying to fix a problem. This is where you find the most cool stuff. You know, almost all of the successful companies that have reached elbows of scale and hurtled over them is where developers and operations come together to come up with unique solutions. You know, trying to think of examples. Memcache is a perfect example of this, right? It used to be that databases were like DBAs and ops people. That's their, you know, that was them. I don't know, I'm a developer, I'm going to write code, and there's a magical database somewhere that does answers for me. You know, Memcache was written, and various architectures were designed to solve this problem, and the only way that it happened is when developers and operations work together.
Now, if you're dealing with someone who is just saying no, if you're trying to solve a problem and you know that the response from your colleagues in the other team is going to be to say that that's a really bad idea, then hiding your solution from them is just a really, really bad idea. If John's going to say no to something that I want to do, then it's probably for a really good reason. And by hiding it from him, I'm not giving him an opportunity to provide his expertise. More importantly, if I'm going to hide something from him, he's going to find out about it eventually, and he's going to be pissed when he does. Again, for the developers, one of the things that you can do to really kind of get that sense of respect about your work is to talk to ops up front before launching something or before proposing something about what the impact of it's going to be. If you're going to push some code live, what metrics are going to change? What boxes are we going to see more CPU usage? What boxes are going to get more free memory? What are the risks that something might go wrong? What are the signs that something is actually going wrong? So what should the operations team be looking out for? And if something does start to happen, what are the contingencies? How can ops recover to make sure that the site carries on working? The problem with coming up with these answers is you're going to need to work out these answers before going to talk to ops. And you might not have all of the answers, but you should at least use this as the basis of a conversation.
Which leads us to trust. That last slide has a bunch of things and sort of recommendations to help frame this conversation. It means, you know, if a developer comes to ops guy, grumpy ops guy, but he's not going to be grumpy for too long, and says, hey, I'm thinking about pushing this. I think it's going to change load characteristic on cluster A, B, and C. I built this. There's this little hook. You can set this to 0. If something goes awfully wrong, blame me for it. We got to do it. We got to put this piece of code in because of this feature, blah, blah, blah. Now, ops person is like, shit, this guy was really thinking. And not only that, but he cares about this. He cares about the uptime of the site, and he cares about not waking up my team in the middle of the night, which is about trust. Ops need to trust dev to involve them on feature discussions. So you're talking amongst yourselves about, we got a feature, new, awesome, and think to yourself, hey, should I talk to ops about this? Maybe we should tell ops about this. And I'm not talking about I'm not talking about regular operation stuff that should happen early, like capacity planning. That's a given. I'm talking about changes that happen to the site.
And the development team needs to trust that operations are going to discuss infrastructure changes with them ahead of time. They're not going to find out that that PHP has just been upgraded to PHP 5 the day after it happened. Again, it sounds like a really obvious thing to do, but I've worked in some really dysfunctional teams in the past where this wasn't accepted as a necessity. And it comes back to everyone trusting that everyone else is going to try and do their best for the organization as a whole.
Yeah. If you think, I don't want to tell Jim because he's going to freak out, so we're just going to do it anyway. Well, that just means that you're a fucking cowboy, and you don't want the ops people doing that either. And cowboys are losers. So
something practical that we do to help make sure this conversation happens is, as much as possible, we try and create shared runbooks and shared escalation plans. So John and I will sit down together looking at a new feature, or members of our team will sit down together and work out how exactly this new feature is going to be supported operationally, and what the scenarios are in which it might go wrong, who needs to be involved in fixing those, and that just forces the conversation to happen around what are the risks, what are the contingencies, and it makes sure that everyone's on board.
We can't say this too much. Providing knobs and levers for developers to monitor and watch the code that they've been slaving over, and developers writing hooks and knobs and levers such that these things can be operationalized.
It's not enough for you to just throw a piece of code over the fence that has all of the assumptions around all of the variables pre-compiled in such that operations can't change it. If you think that having 20 child processes is a good number, you need to make that something that ops can configure so that if they upgrade the hardware underneath it, then they can run that themselves.
Controversial slide.
Do you want to take it?
Sure. I believe that ops people should make sure developers can see what's happening on the system without going through operations. There's nothing worse than having to play phone tag with shell commands. It's just dumb. By the way, developers are writing the code that are running on your machines. And if you have of course, guardrails are one thing, like Heiliger had said in his keynote. But giving somebody a read-only shell account, even if you're super paranoid on production hardware, it's really low risk, and they can actually see what's happening. Beyond the metrics that you're now sharing, because you're a sharing type of operations person, it means that they can actually get into the guts. Make sure that they can access all of the metrics, not just the ones that you have in Ganglia or Nagios and that sort of thing. They should take a look at what's going on, and you shouldn't be afraid to allow them to do it.
We're not saying that every developer should have root on every production box, although I've got root on some of them.
Yeah, you do.
But a read-only account is a very, very low risk, and as a developer, it's very, very difficult to diagnose things that you could be doing better in your application if you can't even see the log files that it's making, and you can't even see the process tree, so you can't see how much CPU that individual application is taking up. It's very, very difficult to help operations if you don't have access to the machines. Okay. The third aspect of culture that we wanted to talk about is what we think of as a healthy attitude around failure. The important thing to realize here is that failure is going to happen. It's not a question of if, it's a question of when. And if you're spending all of your time thinking about how you can prevent failure, then you're not spending any time considering how you're going to respond to failure when it happens. As an example, airlines, airline pilots spend hours, days each month in simulators, planning for what will happen if fuel cuts out, what happens if they lose an engine, what happens if... But then still...
What happens if I have to land on the Hudson?
Yeah, but still, they also develop procedures to help them when something goes wrong, and you know, evacuation plans and so on. If you want to think about this, one way to think about this is if you're in a site outage, you know, if you're having some kind of medical problem, would you rather be treated by an EMT that deals with a heart attack once a year, or would you rather be dealt with by an EMT that deals with a heart attack, you know, every few weeks? So one of the things that you need to develop in both your operations team and your development team is the ability to respond to problems quickly and effectively. Of course, if you're dealing with outages every single week, then
you get bigger problems.
Then you've got bigger problems. So we come back to the idea of fire drills. Whenever we have an incident at Flickr, then we'll have whoever's on call from the operations team and maybe a couple of senior engineers working to resolve that problem as quickly as possible. And one of the things that I've started doing is sending a message to one or two of the junior engineers on the team saying, look, just assume that no one else is in the office. Assume the site's just gone down, you're the only person around. See if you can work out what you'd do to fix it. Don't actually make any live changes, but just see if you can diagnose it at the same time. And then after the outage is over, then we compare notes. And that's a way of just training some of our more junior members of the team how to respond to these kind of problems.
Yeah. Avoiding blame. It sounds like a really basic thing. We've got a rule of no finger pointing. It's not a rule that we really have to enforce, actually, because we have this. I'm extremely lucky to be involved in an organization that will actually take blame as soon as it comes. Ooh, wow, we're really close. Let's go. So here's like a regular problem, a problem in an unevolved world. So the problem happens, and then, oh my God, what the fuck? What am I going to do? Maybe it was my change. I'm not sure. I don't want people to know what's going on. I'm going to delete the logs. What's going on? And, you know, chicken head cut off. And then it's not my code. It's your machines. Then you finally get around to figuring it out. There's a shitload of waste time, right? You've got territorialism getting in the way of fixing stuff. Here's a suggestion. You could do it this way. You could figure it out. You could fix things, and then later, if you want to feel guilty about it, then you can. This is generally what happens. This is generally what happens at Flickr. And actually, if anything, both in my team and in Paul's team, we end up having people just falling over themselves, trying to prove actually that it was their fault. That broke it, because, you know, 10 times a day, who knows, right?
Then they can be the guy that fixes it, I guess.
Yeah, and they can be the guy that fixes it.
There's something weird going on there.
Yeah. Again, underscore something we already said. Remember, developers, when you write code, somebody else will wake up in the middle of the night. There are those organizations that put devs on call. If you think that something might happen in the middle of the night and you're not going to be around, or you're going to be at Thanksgiving in St. Martin, other people are going to fix your shit.
Even if you have devs on call, it's generally the ops team that get
this is true.
Very first page. So, and if you're in the scenario where you've broken something in the middle of the night and you come in the morning after and find that it was your fault, that there was a half-hour outage and that 5 people got paged and woken up, then you can just say sorry. It makes people feel better about it.
Yeah, and if you don't say you're sorry, it sends the message of, well, screw you, aren't you getting paid extra for being on call anyway?
And something I see a lot of development teams do is they rely on the fact that operations are there, that operations are going to get woken up in the middle of the night to fix their stuff for them. One of the questions you can ask yourself is, what would I do differently if I didn't have someone there picking up my slack? And if you can think of things that you'd change, if you were the one that was getting woken up in the middle of the night, then maybe you should be changing those things.
Operations should provide constructive feedback, continual feedback on how things are going. You know, these guys are writing code to make your business run and to get more users and to take over the planet. So they should know how things are. Don't gripe about it. Explain to them what's going on and say, hey, look, you know, I noticed that that this cron job that happens every 6 a.m., blah, 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 it's not that big of a deal, but it does go boop, boop, you know. Explain to them. There's all kinds of metrics. You know what you want to look at. They know what they want to look at. Just share the information.
So to summarize,
good.
6 tools you should think about using, and 4 aspects of your culture you might want to think about changing. Automated infrastructure, shared version control, one-step build and deploy, feature flags, shared metrics, IRC bots, respect, trust, healthy attitude towards failure, and avoiding finger pointing.
To be clear, this is definitely not easy, but you're free to continue on freaking out on each other if you want.
Thank you for your time.
Thank you.